Okay, hi everyone. So we are going to start in some time. So just wait for others to join the class, then we'll start. Okay, everyone. Good evening. Good afternoon. Sorry. So Rahul is saying hi anyone. Hi everyone. Can anyone confirm which ID we are using to write a Python code? As I recently joined, so you can use a VS Code, Rahul. Okay, so everyone, good afternoon. So let's start with the class and let me share my screen. So today we are going to start with the actual concept of a data science, which is called as machine learning. We are going to start, and today we are going to start ahead with the very first algorithms, which is called as linear regression inside a machine learning. And in today's class, so I'm going to give you a complete, not just an overview, in-depth intuition that when we say we are trying to build a model, when we are saying that we are trying to train the model, so what happens in between and how system try to calculate, because at the end of the day, model is all about building some sort of a mathematical equation, right? So it doesn't matter which model you are going to build, but yes, at the end of the day, it is going to be a mathematical equation. So how do we use, or how do we build those mathematical equation? How do we use it? How it is going to train itself? How it is going to make a prediction? Each and everything we are going to understand and we are going to discuss in this particular class. Yes, guys. So shall we start? New interface is good, sir. Thanks, Masood. Shall we start, everyone? Yes, let's get started, guys. And believe me, in a beautiful manner, I'm going to explain you each and everything. So after today's class, you will not be having any kind of a thought like how training actually happens and how we used to build a model. Each and everything will be clarified mathematically to all of you, and programmatically tomorrow we are going to touch upon each and everything. So we'll try to take the data, we'll perform the EDA operation, we'll try to build a model, we'll try to fine tune those models, and then we are going to build a final app and then a deployment. So that is something which is going to happen in my tomorrow's class based on today's class itself, right? So where to adjust the video quality? Don't worry, you don't have to worry about the video quality. So video quality will be super fine going forward, and even with the low bandwidth, you are not going to face any kind of a issue. Arvindan, yeah. So let's get started, guys. So here, whenever we say we are trying to build a model, so what is the meaning of this, guys, by the way? So whenever we say that we are trying to train the model, or we are trying to train the like a model based on top of our own data set, so what is the actual meaning of it? Let's try to understand that particular part. So let's suppose I have a data, right? So let's suppose I have a data, or maybe in a X coordinate and in a Y coordinate. So I can try to plot those data. And let's suppose that data set is trying to showcase some sort of a trend to us, right? Some sort of a trend to us. Now, so if data set is trying to showcase some sort of a trend, so as of now over here, so we have a data on X axis and we have a data on Y axis, and it's clearly visible over here that when X is increasing, right, even Y is increasing. So it is trying to show me some sort of a trend. It is trying to show me some sort of a trend, although data is scattered over here a little bit. We have a variances over here, but still I can say that this data set is trying to showcase a trend. Or maybe I can try to take this kind of a data set, and even this is going to show me some sort of a trend. Or maybe I can try to take even this kind of a data set, and this is going to showcase some sort of a trend to me. So every data set is having some sort of a shape over here, and whenever we have some sort of a data set with respect to a certain shape, we can say that yes, it is trying to show me some sort of a relationship between my X and my Y. Now here, my X is nothing but my input and Y is nothing but my output. Let's assume that, right? That X is going to my input and Y is going to be my output, and data set is trying to showcase a trend. If data set is not showing any kind of a trend, we can't do anything. We will not be able to build the model. Or even if we are trying to build a model, it is going to be the worst one. Why? We'll try to understand that part as well. But here, so let's suppose my data set is trying to showcase some sort of a trend in this particular place. Now, there is a possibility that I can try to generalize it. I can try to generalize it, and maybe I can try to draw a line for this particular data set. I can try to draw a line, and I can say that this line is trying to represent a nature of this entire data set. I can say that, right? Hypothetically, I can say that this line is trying to represent this nature of the data set, or maybe this line is representing a nature of the data set, or maybe this curve is representing a nature of this particular data set. Now, so if I'm saying that this line is representing a trend inside a data, or maybe it is trying to represent an overall set of the data that we have. So what we can do is, maybe for this line, I can try to write an equation. And we all know that what is the equation of the line? It's basically y is equals to mx plus c, where c is nothing but an intercept. So value of c is, so if I'm going to write y is equals to mx plus c, so when x is equals to 0, y is equals to c, means when x will be equal to 0 here at origin. So what is a value of c? So value of c is going to be this one, the red one, right? So this is going to be the value of c, and this is something called as intercept. Basically, this is something called as intercept. And then what about this m? So let's suppose c is equals to 0. C is equals to 0. In that case, what is going to be my m? So in a like simplest way, so y by x. So it's nothing but it's a tangent, or I can say it's going to be the slope for me. So at any point of a time, if we are going to find out what is angle or what is a tan theta over here, so this is something which has been represented by m. In other words, it's also called as a slope at the end of the day. But yeah, the whole idea behind drawing this line is that it will be able to adopt a trend inside my data set. Now, so when I'm saying that line is trying to adopt a trend inside a data set, I can try to draw not just one single line. So maybe I can try to draw infinite number of lines over here. It's not just one single line, right? So I will be able to draw infinite number of lines in a very, very small region itself, just by changing a value of m and value of c. Because if value of m and value of c is changing, so obviously my line is going to change. So there are infinite number of lines I will be able to draw, or I can try to fit in for this particular data set. But I don't want those infinite number of lines. What I want is, so I want a single line at the end of the day. So where, right? So where it should be a best fitted line for me. So where it should be the best fitted line for me, which is going to generalize, or which should be able to generalize the nature of the entire data set. And that is a line that we are supposed to find out. And to find out that line, we have to find out value of M and we have to find out the value of C, because value of M and C is going to define the nature of the line, or what kind of a line we are going to draw. Any line in this space, if I'm going to draw at the end of the day, for any line, it's going to be M and it's going to be C. And if I know M, if I know C, I will be able to draw a line. And if I'm able to draw the line, I can try to pass a value of X over here, right? And it is going to give me a value of Y. So if I know M and C, somehow, I don't know how as of now, right? We have to prove that part. But yeah, somehow if I'm able to find out a value of M, and somehow if I'm able to find out the value of C, then my equation will be complete. And then I can try to pass the value of X, I will be able to get a value of Y. For example, hypothetically, as of now, I don't know value of M. Hypothetically, I'm going to consider value of M is equals to 5 and value of C is equals to 2. Then the equation of my line is going to be 5x plus 2. Now, if this is the equation, and if I'm going to pass a value of X, I will be able to get a value of Y. Making sense, guys, to all of us? Yes? Everyone? Technically, can I say this? Everyone? In a chat, guys, everyone? Yes. Okay. So technically what we are supposed to do is, so we are supposed to find out the value of M and value of C. I don't know how as of now, we'll figure it out, right? We'll try to prove some sort of an equation over here, but we have to find out the value of M, value of C for any kind of a given data set for me. Now, there is a possibility that I could have multiple X, means I have multiple columns. X means multiple columns I will be having. So my equation will be M1 X1 plus M2 X2 plus M3 X3 and so on, Mn Xn plus C. Possible, right? Possible if I have n dimension data, but let's try to prove it with respect to 2D. Similarly, it is going to work for the ND kind of a data set, n dimensional data set at the end of the day. Okay. So the major problem over here is to find out a value of M and a value of C. And somehow if I'm able to find out a value of M and value of C, I will be able to draw a line which is going to represent my nature of the data set. And eventually in future, if I'm going to get any value of input or any value of X in future, I will be able to tell you that what is the value of Y, and ideologically it's called as prediction. So we will be able to make a prediction. So major problem over here is to find out a value of M and a value of C for this linear regression that we are talking about. So this kind of a problem statement, so where data set is going to show you some sort of a relationship in a linear manner, it falls under a algorithm called as LINEAR, linear regression. So regression means we are trying to find out some sort of a continuous value over here. Maybe like an integer, maybe a floating point number. So some sort of a continuous value we are trying to find out. And linear means that data set is having some sort of a linearity in nature, and based on that linearity in nature, so we are trying to fit in some sort of a line over here. Now to fit in those lines, I need a value of M and I need a value of C technically over here in this particular place. Okay, so if this is the case, right? If this is the case, now let's try to take one small data set, one very, very small data set in this particular place. So let's suppose, right? So let's suppose I'm going to take one small data set over here. So value of X. So for example, a value of X is 1, 2, 3, and 4. And someone has given me a value of Y is equals to 5, 7, 9, and 11. So I have a value of X and someone has given me a value of Y over here. So value of X is 1 and value of Y is equals to 5. You can try to even draw that part. So we have a X axis over here and we have a Y axis over here. We have a 0.0 coordinate over here. Now 1, 2, 3, 4. So 1, 2, 3, 4 on x-axis, and then y-axis maybe 5, 7 we have given. So I'll take 2 scale, then 4, and then 6, and then 8 scale. This is the scale which I have taken. So now if I have to represent this first data set 1 and 5, so x is equals to 1 and then y is equals to 5. So 5 will be somewhere over here and 1 is here. So 1 and then 5. So maybe my point will be here. So this is my point number 1, data number 1. My data number 2 says that 2 and 7. So 2 and 7. So 7 will be somewhere over here. And then we have a 2 over here. So this is my data point. Then we have 3 and 9. So maybe we have 8 and 10 and then 12 somewhere over here, extending this same line. So here, so we have somewhere like a 3 and then we have somewhere like a 9. So we have a point, this 3, 9 over here, and then we have 4, 11. So somewhere we have 4, 11 in this particular place. Now here I can try to draw maybe this line. I can try to draw maybe this line. I can try to draw maybe this line. So there are infinite number of lines which I will be able to draw. But technically I have to find out that which line is going to represent in a best possible way this relationship which is given inside my data set. That is something which I am supposed to find out. And at the end of the day, so equation of line is going to be y is equals to mx plus c. We just have one value of x. If we have a multiple value of x, then in that case m1 x1 plus m2 x2 plus mn xn plus c. So this is something that I can try to write. But as of now, I just have only one value of x. So this is the equation which will comes into a picture. And I have to find out the value of m. I have to find out the value of c. Now, how will I be able to find out a value of m and a value of c over here? So hypothetically, right? Hypothetically, let's try to consider a value of m is equals to 2 and the value of c is equals to 1. I don't know whether this is the correct value or not, right? I'm not having any idea. Literally, I don't have any idea. So I'm just trying to take some random value of m and some random value of c. So now my equation will become 2x plus 1. This equation will become 2x plus 1. Correct, everyone? I have taken a random value of m and c, guys. I don't have any idea that what is going to be the actual m or actual c. I don't have any idea about the best fitted line which I can draw for this particular data set, which is going to like show you the relation in a best possible way. I don't have any idea as of now. So I'm just trying to start with a random walk, and I have taken m is equals to 2, c is equals to 1. You can take any other value that you want. No issue at all. It's completely fine. Just go and consider any value of m and c. So now my line will become this one. Y is equal to 2x plus 1. Yeah, y is equal to 2x plus 1. Now, let's do a prediction. So let's try to draw one more column. So here y hat. So when m is equals to 2 and c is equals to 1, right? Or m is equal to 2 and c is equals to 1. Let's do a prediction. So if I have to do a prediction, so what will be the prediction, guys? So here x is equals to 1, right? So if x is equals to 1, then what is going to be y? So y for x is equals to 1. For x is equals to 1 is going to be 2 into 1 plus 1. So is going to be 5. So okay, it's going to be 5. Fine. Now y for x is equals to 2. So 2 into 2. Sorry, x is equals to 1, right? 2 into 1 plus 1, 3. Now x is equals to 2. So 2 into 2 plus 1 is equals to 5. So this is going to be 3, this is going to be 5, and then y when x is equals to 3 for third value. So 2 into 3 plus 1, so is going to be 7. So okay, it's going to be 7. Now y when x is equals to 4. So here 2 into 4 plus 1, so it's going to be 9. So it's going to be 9. Now this is the y prediction. So based on the equation which I have chosen, based on the m and c that we have taken. So based on that, this is the value of prediction y hat. It's called as y hat actually, right? Y hat simply means that whenever I'm going to write y hat, it simply means that it's a prediction that we are trying to find out. So y hat, so when x is equals to 1, it's 3. When x is equals to 2, it's 5. When x is equal to 3, it's 7. When x is equal to 4, it's 9. So I was expecting 5. So actually, as per my data set, So I was expecting 5 and it is giving me 3. I was expecting 7, it is giving me 5. I was expecting 9, it is giving me 7. I was expecting 11, it is giving me 9. So can I say that this M and C, right, that I have chosen randomly, maybe you can take M is equal to 10, C is equals to something else, 100 or something, right? So can I say that randomly the value of M and C which I have assumed, right, by myself, it's not a perfect M and C? Can I say that? The value of M and C which I have chosen, it's actually not a perfect value of M and C for my data set, because I'm expecting something else. It is giving me some different result, which is a kind of a deviation from my actual result. So can I make a statement over here that the value of M and C which I have chosen over here, it's not perfect. Maybe it's nearby, but still it's not perfect at all, right? It's not perfect at all. It is not able to represent the generalization of this particular data set. Now, what we are supposed to do if we are not able to get the value of, because this is the random value which I have chosen. If I'm going to ask you, so some of you maybe take a value of M is equals to 200, value of C is equals to 50 or any number, right? There could be an infinite number of combination that you guys can choose when you don't have any kind of idea. And in any of such situation, you will not be able to find out the relevance between Y and Y hat, means the actual expectation and the prediction that we are looking for. Okay. So what we will do in that situation, if we are not able to find out, like if we are not able to assume, or if we are not able to think about a actual value of M and C, which should be relevant with respect to my data set, which I have chosen over here. So what I should do in that situation? Any idea, guys? Any thought? See guys, at the end of the day, I have to find out the value of M and C so that I will be able to find out the best fitted line, which is going to be the generalization for my data set, a trend of my data set. So what I'm supposed to do, guys, over here? Any thought, any idea, anyone? Yes, any idea, guys? Okay, no idea. Okay, that's great, because this is something that we have to learn, right? This is where we will try to understand. So what we are trying to build, how training happens. So maybe average of the input data. No, not at all. So like average of input data, what it will do with you? Like how you will be able to find out the value of M and C. Okay. So apply optimizer for update M and C. Okay. So there are some people who know the things, maybe little bit or maybe 100%, right? So Ganesh and Karan, by the way. Now, rest of them are saying like some wrong answer and more combinations. No, not at all. See, I'm not supposed to go with a random combination, right? Because random combination wise, I will end up like taking an infinite number of combination on a number scale. I'm not supposed to go and try with the infinite number of combination. I don't have that much of compute, basically. So here, what we are supposed to do. So there is a function called as loss function. So here, what we are supposed to do is, so we are supposed to find out the loss when I have taken M is equals to 2 or M is equal to C, or M is equal to 2 and C is equals to 1 for any M and C that you are going to consider initially. So there is a loss function, and loss function name is basically MSE. MSE, mean squared error. Now how we can write it down? So mean squared error is 1 by n summation of I is equals to 1 till n y minus y hat of a square. This is what it means. This is a loss function. This is basically a loss function. This is basically a loss function. Now, so this loss function is going to tell you that what is a total loss that you are getting. So when you have a difference between y and y hat. Let's suppose if I am able to find out, hypothetically, again hypothetically, let's assume that if I am able to find out the perfect value, right? The perfect value of M and C, if I am able to find out. I don't know how, but yeah, as of now, just assume that if I am able to find out the perfect value of M and C, in that situation, can I say that this component is going to be 0? Can I say that? Because there will be no difference between y and y hat. if I'm able to, hypothetically again guys, right, as of now. So if I'm able to find out the perfect value of M and C, right? So can I say that I will be able to find out y and y hat same, and if y and y hat is going to be same, my loss is going to be absolute 0. Agree everyone? Yes? Okay. Now this is the label that we have to achieve. So this loss function always talks about a difference between your y, which you are expecting, and the y hat that you have predicted here itself, right? We have y and y hat. And if I'm able to find out a exact y hat, which is equal to my y expectation, in that case, this loss function, as you can see from the function itself, right? This difference is going to be 0. This difference is going to be 0 means the entire component is going to be 0, means there is 0 loss. Right? There is 0 loss at the end of the day. So this is the place, or this is the thing that we have to achieve at the end of the day. This is something that we have to achieve. Okay, fine. Now, so let's try to do a calculation. Just for the simplicity, I'm doing this calculation. So let's try to find out a y hat when m is equals to 0 and c is equals to 0. Just for the simple calculation, so that I can derive the entire calculation and show it to you, right? So when m is equals to 0, let's suppose when m is equals to 0 and c is equals to 0, right? So in that case, m is equals to 0, c is equals to 0. So in that case, can I say that my equation will be 0 into x plus 0. So y is equals to 0. Can I say that? Y is equal to 0. So whatever data you are going to input, as a x, it is going to give you eventually 0. If m is equal to 0, c is equal to 0. So your prediction is going to be 0, 0, 0, 0. Your prediction is going to be 0, 0, 0, 0, right? Your prediction is going to be 0, 0, 0, 0. Here, y hat. If m is equal to 0 and c is equals to 0. So previously I have taken m is equal to 2, c is equal to 1. This time, again, I'm trying to do an experiment, and then I have taken m is equal to 0, c is equal to 0. So my prediction is also going to be 0, 0, 0, 0. Okay, that's fine. Now, let's try to do a math for this MSE. So what is going to be the mean squared error? Here n is nothing but number of data. How many data we have? We have 4 number of data, right? We have 4 rows over here, right? So 1 by 4 n. Summation of I is equal to 1 till n. So data number 1 till last. Y minus y hat. For this 0th one, I'm trying to do the computation. So here 5 minus 0 of a square, then 7 minus 0 of a square, then 9 minus 0 of a square, then 11 minus 0 of a square. Now what is the value, guys? What is the value that I will be able to achieve? What is the MSE? Mean squared error. This is called as mean squared error, which is technically a loss function. So Shivani is saying loss is equal to 0. How loss is going to be 0, Shivani? So just calculate the math. Do the math with MSE. There is a difference between y and y hat, right? 5 minus 0, 7 minus 0, 9 minus 0, 11 minus 0. So it's not going to be the 0 one. So MSE is not going to be 0. Do the math over here, guys. Give me this value. This particular value. 1 by 4 into. So basically 5 minus 0 square, 7 minus 0 square. So technically it's going to be 1 by 4. 1 by 4, 5 square plus 7 square plus 9 square plus 11 square. Now do the math, give me the value. Sir, I am asking कि real time में loss 0 होता है? Loss will always try to tend to 0, or we will try to minimize as much as possible. Absolute 0 you won't be able to find out. If your data set is like absolute perfect, then maybe. But yeah, ideal cases, no. But it should tend to 0. So Masood is saying that my MSE is going to be 69. My mean squared, Sada is also saying the same answer, right? So my MSE is 69. So what is my loss as of now, guys? So my loss as of now for this value is 69. Okay. So this is the loss that I'm able to find out. Now, what is my responsibility? See, why I'm getting this loss? Because I have taken a value of M and C, or I'm trying to draw a line which is not a best fitted line for this. And my loss is very, very high. It simply means that M is equal to 0, C is equals to 0 is not a best answer for me. It's not a best case result for me. So maybe I have to find out some other value of M. Maybe I have to find out some other value of a C, right? Now, how we are going to find out, because we have a loss over here and my responsibility is to reduce a loss, right? Reduce a loss. Reduce a loss means come closer to the trend of the data. This is what it means. Means reduce the difference between Y and Y prediction. And that is my objective, because if I'm able to reduce a difference between Y and Y prediction, which is very, very huge, 5 versus 0, 7 versus 0, 9 versus 0, 11 versus 0. So in this situation, which is very, very huge, so somehow if I'm going to reduce, right, somehow if I'm going to reduce this loss, maybe I will be able to find out the better result. Okay, now guys, just try to do the calculation. So MSE, right, when m is equal to 2, c is equals to 1. So this one, 5 versus 3. Just do the math, 1 by 4. So 5 minus 3 of a square, then 7 minus 5 of a square, plus 9 minus 7 of a square, plus 11 minus 9 of a square. Now what is the loss, guys? So 1 by 4. So everywhere 5 minus 3, 2, 7 minus 2, 2, 2. So 2 a square. So 4 plus 4 plus 4 plus 4. So technically it's going to be 16 by 4. It's going to be 4, right? So in this situation, so when I have considered this one, my loss is going to be basically 4. And when I have considered m is equal to 0, c is equal to 0, my loss is going to be 69. Yes, my loss is going to be 69. Now tell me, guys, now tell me. So if I have to consider my line, if I have to take a line, if I'm giving you two options, right? So choose this versus this. So which one you are going to choose? Choose this versus this. So choose m is equal to 2, c is equal to 1 versus m is equal to 0, c is equal to 0. So which one you are going to choose, guys? Quick, everyone. So you are going to choose basically what? So you are technically, right? So you are going to choose, yeah. So you are going to choose basically m is equal to 2, c is equals to 1. Why you are choosing this one? So can I say that because loss is less over here, right? Loss is less over here. So as compared to the other one, I will be able to get a better result. I will be able to get a better answer in this case. And that is the reason. So you are saying that you are able to make a statement that, okay, so if I have to choose between these two, I will prefer to choose m is equals to 2, c is equals to 1, means I'll prefer to choose y is equals to 2x plus 1. This equation for this particular data set, because with this data set, this equation is giving me less loss, right? Your MSE mean squared error is less. But here again, the thing is that I have taken this value of m and c manually in both the situation. M is equal to 2, c is equal to 0, manual. Again, m is equal to 2, c is equal to 1, manual. I have taken. How system will be able to find out the same thing, right? How system will be able to find out the same thing. That is something called as training. Now we are going to learn that how system will be able to find out the value of m and c. So here, when there is a loss, right? Whenever there is a loss, so is always we have to choose a less loss, very low, right? Exactly. That's the whole idea, right? Because less loss means more accurate prediction. Means whatever equation you have taken, it's more closer towards the trend of the data. So now all these things are completely fine. Now how system will be able to calculate a loss? Because at the end of the day, I have to choose a new value of m. So m new I have to find out, and m new, and I have to find out basically c new. So let's suppose I have chosen initially, I am trying to start with a random value, m is equal to 0, c is equal to 0 initially, right? So initially, and I have observed that I'm getting a loss. I have observed that I'm getting a loss. So here m is, so I have to find out a new value of m and new value of c. So what could be the new value of m, new value of c? And I'm trying to start from, let's suppose 0, 0, right? Or maybe I can try to start from any random value. That's completely fine. Eventually, I have to reach out to those value of m and those value of c. So where it should be giving me a less loss. Means it should give me the perfect equation. Okay. So m new. So we'll have to update a value of m and we have to update the value of C. As of now, I am starting with 0, 0. So M is equal to 0, C is equal to 0. So M new is nothing but M old minus, there is a parameter called as eta. This is called as eta, right? Eta. Now partial derivative of mean squared error by, with respect to basically M, and then C new, intercept new is nothing but C old minus eta, and then partial derivative of loss with respect to a C. So this is the equation. This is the equation which is going to help you out to find out a new value of M with respect to the old value, first of all, minus eta. Eta is nothing but it's called as learning rate. I'll try to explain you that part as well. So it's basically a constant that we try to choose. It's a trainable parameter that we try to assume. Why we try to assume? I'll explain you that part as well. Into root partial derivative of this mean squared error, because whatever we have to choose, so we have to choose with respect to mean squared error. So partial derivative of mean squared error with respect to M, and partial derivative of mean squared error with respect to C. Somehow, I don't know how as of now, but somehow if I'm able to find out this value, somehow if I'm able to find out this value, then I will be able to find out the new value of M and new value of C. And I will keep on doing this. I'll keep on doing this unless and until I'm not going to optimize my loss, unless and until I'm not able to reach a point where my loss is going to be minimum. Yes, where my loss is going to be minimum at any point of a time. So that is something. So I'm just trying to reduce the loss as much as possible, as minimum as possible. So that is something that we have to reach out. Okay, fine. Now, how I will be able to find out this partial derivative, by the way? So equation of MSE, equation of mean squared error is nothing but 1 by n, summation of I is equals to 1 till n, and then y minus y hat of a square. This is the equation. This is what MSE is. Now, partial derivative of anything, right? Partial derivative of MSE if I have to find out. So any idea, guys, how will I be able to find out the partial derivative of MSE? Yes, partial derivative of MSE. Okay, so I can try to write this equation even in this way. So just try to write this equation. So summation of y minus y hat we have, right? So y hat I can try to write it down into, so m of xi plus c and then a square. So I'm just replacing this with this line, equation of the line, simple, right? So equation of the line, because this is the line which is going to give me a prediction. So I'm just replacing it with this. Now what I will do is, so let's try to consider this one. So let's try to consider this entire entity, for example, as E for now, just for simplicity. So summation of E square. I'm considered this entire thing. So my E is nothing but y minus mx plus c. So this is this entire term I have considered as a E for now, just for the simplicity I have considered. So now my MSE is technically E. Right? Now my MSE is technically a E over here. Now, if I'm going to ask you that try to find out a partial derivative. So basically a partial derivative of y with respect to x is nothing but, so we try to introduce another variable z, and this is actually equal to this. So partial derivative of y with respect to x is nothing but a derivative of y with respect to z and z with respect to x. Technically z and z will get cancelled. So I'm just trying to introduce two values, right? So this is something called as partial derivative. And again, so we all have studied these things in 9th and 10th. So this is something called as partial derivative. This is how we try to find out. Okay, so if I have to find out a partial derivative of mean squared error with respect to a m, so how I can write this equation? So partial derivative of this one I can maybe write in this way, 1 by n, and then summation of 2e. So derivative of this e square, and then derivative of e with respect to m. This is what I can try to write it down as a partial derivative of MSE. A simple math, guys. Simple math. No hypothetical things, right? So here dy by dx. So basically MSE by m. Simple, right? Now dy by dz. What is z? So I'm trying to reduce z as e. Simple. So dy by gz. So what is the differential of this one? So differential of any x to the power n is what? N into x to the power n minus 1. This is what a differential is, right? For any x to the power n, n into x to the power n minus 1. So fine, we have a power 2. So 2 into e to the power 2 minus 1, which is eventually 1 into simple dz by dx. So here d by dm. So here we are trying to find out the partial derivative. Now, this is something that we are able to find out as a partial derivative of this one. Now again, still we have a derivative, right? Still we have a derivative over here. So we have to find out somehow this particular values as well, because we have a derivative, we have to remove it. We have to do the mathematical calculation over here, right? So what will be this term d by with respect to m? So what was e, by the way? E was this, right? So e was this. So it's nothing but this equation y minus mx plus c, right? This is something which I have taken as e. So what was e? E was this, right? Now find out the derivative, guys, derivative of this entire term with respect to m. So can I say that this by this y minus mx minus c. Now find this derivative of this with respect to m. So what will be the derivative, guys? Anyone? What will be d by dm? What will be d by, now it's very simple, right? With respect to m, we are trying to find out. So this is constant. Constant derivative for constant is 0. This is constant. So because with respect to m, we are trying to find out. So what is the derivative? Can I say it is going to be minus of x? This will be 0. This will be 0. This is nothing but m to the power 1. So 1 into m to the power 1 minus 1. So 0. M to the power 0 is equal to 1. So minus of x. So can I say that this is going to d by dm is giving me minus of x. Yeah, minus of x. Simple calculation. So now I can replace this term with minus of x. So now this entire equation, right? Now this entire equation will become summation of 2e minus of x. Can I say that? Yes, 2e minus of x. This equation will become 2e minus of x. Agree, everyone? 2e minus of x. Now let's try to substitute the value of e over here. So 1 by n, let me write it down here. MSE by m, right? It's basically summation of 2e minus of x. Okay, so I can write it down in this way. Summation of, what is the value of e, by the way? So value of e that I have considered in this particular place is y minus mx plus c. So y minus mx plus c and into minus of x we have. So I'm just trying to substitute the value of e over here. Now, so if you are going to solve this entire things, right? If you're going to solve this entire things, if you're going to break it down, no need to solve over here. So 1 by n summation of, so 2 into e, so 2y minus 2mx plus 2c into minus of x. Now again, if I'm going to rewrite this one, so here minus 2xy plus 2xm minus 2xc. Okay, fine. So this is something which I will be able to find out over here. Now I'm trying to take minus 2 common because minus 2 is common everywhere. So minus 2 by n, and even x I'm going to take it out, not here I'm going to write. So minus 2x if I'm going to take out, so it's going to be y minus 2 if I'm going to take out from here, so it's going to be m and minus 2x, so minus c, sorry, some x square, right? So mx, yeah, mx. So now if I have to rewrite this equation, so x y minus mx plus c, I can write in this way. So ideally it's going to be minus 2 by n summation of x y minus, this is basically a y hat. So now my partial derivative of MSE with respect to M is what? This one. Can I say that, guys? Partial derivative is basically this one. Now I know the value of X, I know the value of Y, I know the value of Y hat. So can I say, if I'm going to substitute this value into this equation, right? This is, let's suppose, equation number 1. This is equation number 2. So I will be able to find out a new value of M. Let me rewrite that over here. So my new value of M is nothing but old value of M, learning rate, MSE, rate of like a derivative of like a mean squared error with respect to M. Now here I know this value. So M0 minus eta, and then it's going to be 2 by n summation of X into Y minus Y hat. Can I rewrite this new M in this way? Everyone? Can I rewrite my new M in this way, guys? टू सी आएगा, minus 2c, where, guys? Somewhere I have made a mistake. I think I have rectified it. So there was a mistake with respect to a square. So I have rectified that part. So anywhere, guys, I have made a mistake. Anything? MCK Joy Masood is saying yes, yes, yes. Where? Tell me. Where, guys? Where I have made a mistake? 1 by n x, then substituting the value of E over here, y minus mx, then breaking it down. So minus, okay. Got it, guys, got it. So here I have made a mistake. Minus 2c. Fine. So minus. Okay. So minus like a plus over here. Minus plus, and then minus plus over here. Then I'm trying to extract a value. Minus 2xy plus of 2xm plus of 2xc. Okay, so this is fine. Then I'm trying to take out minus 2, which is a common one. Then I'm trying to take out the x, minus 2x, which I'm trying to take out. So this is going to be the positive. This is going to be the negative. This is going to be the negative. Yeah. After that, it's fine, it seems. Oh, sorry. I have taken, by mistake, I have taken, but yeah, rectified it. This is what I have assumed, that I have rectified it somewhere. Okay, so yeah, this multiplication is going to give you minus a simple multiplication, right? Okay, so ideally, I'm able to find out a new value of M. I'm able to find out a new value of M over here. Now, let's do the math in this particular place. What was my old value of M? What was my old value of M? So let's imagine, so for M is equal to 0 and C is equal to 0, I'm trying to do the computation. So what was my old value of M? 0. Now, let's talk about eta. So eta always try to define, which is a constant. So eta always try to define that what is a changes you will be able to adopt from this derivative. So a big one or the small one. So in general, it's called as hyperparameter, and the value, the ideal value that we used to consider is 0.001 or 0.1 or 0.01. These are the ideal value. But again, you can try to choose maybe 100, 1000, 10,000. Soon you will be able to see the impact of it. Now here, right? So here, let's suppose I'm considering eta is equals to 0.1, right? Eta is equals to 0.1. 0.1 I'm going to consider. Now, just do the math, guys. Minus 2 by n, number of data is what? Number of data is basically 4. Summation of x into y minus y hat. So let's suppose x is equals to 1. X is equals to 1, the very first value. X is equals to 1. Then 5. So 1, 2, 3, 4, 5, 7, 9, 11. Okay. So here, let's do a manual calculation. So x is equals to 1. So y is equals to 5, y hat is equals to 0, plus x is equals to 2, y is equals to 7, y hat is equal to 0, plus 3, y is equals to 9, y hat is equals to 0, plus 3, plus 4, y is equal to 11, y hat is equals to 0. Okay. Now, can anyone give me a new value of m, guys? M new. So initially I have started with m is equals to 0, right? Now this, with the help of this equation, so I'm trying to find out a new value of m. So anyone, guys, who can do a math for me? So it's going to be ideally like a 0 minus, or I can say minus of 0.1 into 2 by 4, 2 by 4 negative, and summation of 5 plus 14 plus 27 plus 44. Now it became more easy. So what is the value of m, guys? M. And eta is equal to 0.1 I have considered. Learning rate is 0.1. Basically, this learning rate is going to tell you that whatever MSC derivative that you are able to find out with respect to this m, so how much impact it is going to create. And that is something that we used to choose. If you are going to choose a very high, in that case, again, the changes is going to be very, very high. And eventually I'll tell you, so why you should not do that. Yes, guys, do the math. So Sada is saying it's a 4.5. Shivani is saying it's a 4.5 positive because minus minus plus. So it's going to be 4.5. So my m is equals to new m. The new m after this calculation is going to be 4.5. Now that is something which I am able to find out. Okay. Now we are not just supposed to find out a new m. We are supposed to find out new c as well. New c is nothing but old c minus eta differential of this with respect to c. So this is again a component which I'm supposed to find out with respect to a c, right? So old value was 0, right? Now new value of m I'm able to find out. Okay, fine. Now we have to find out a new value of c as well. And this is the equation. So with the help of this equation, I know old value of c. Eta is equals to 0.1 I'm going to consider, same as before. And we have to find out basically this one, right? So again, what is the equation of like MSE? So it's nothing but 1 by n, same equation, summation of I is equal to 1 till n, and then y minus y hat of square. Okay, now I can rewrite in this way. So 1 by n, and then summation of y minus y hat mx plus c, right? Prediction equation of square. I'm going to consider again this one as e. Same as before, as e I'm going to consider. So, okay, it is going to be summation of e of square. So, ideally this is going to be the equation once again. Same as before, it is going to be the equation once again. Now, so if I'll try to find out a derivative MSE with respect to c, so here, partial derivative I'm trying to find out. So same rule will be applicable in terms of a partial derivative. So I can try to write it down in this way, that 1 by n, right? Partial derivative 1 by n, and then I can write it down 2e into with respect to c over here, right? With respect to c. Agree, guys? Till this point, I think we have done the same thing, even like in my previous equation. So we have done the exact same thing. Yes, everyone. And obviously summation of all of these. Joey is saying it's a hyperparameter. Yes, exactly, Joey. How we will decide the learning rate? I'll tell you. Just wait for it. I'll tell you. As of now, like I said, choose between 0.1, 0.01, 0.001. As of now only. Okay. So ideally we have to find out this one. So dE by dC we have to find out. Now how we can try to find out a dE by dC? So dE by dC. So E is what? E is what? So y minus mx plus c. This is something that we have considered as E. Yes, everyone? This is something that we have considered as a E. So I have just replaced it. Now guys, give me the derivative of this entire equation with respect to c. So it's going to be y minus mx minus c. Now, what is the derivative, guys, with respect to c? Derivative of this. So this is constant, will become 0. This is constant, will become 0. Now this is c to the power 1. So can I say that 1 into c to the power 1 minus 1, which is equal to 0. So technically it's going to be minus 1. Can I say that this derivative is minus 1? Yes, this derivative is technically minus 1. Okay, fine. This derivative is technically minus 1. Okay, that's amazing. So let's try to put this value over here. So 1 by n summation of 2e, and then this will become minus 1. So once we are going to put up these things, so it will become minus 1 by n summation of 2e. So can I say that partial derivative of mean squared error with respect to c, with respect to this intercept, is this equation? Agree all? Yes, agree? Okay. Now if I'm going to rewrite this one, so 1 by n. Now what was my e, by the way? So here let's take 2 summation of, so what was e, by the way? So e was nothing but y minus mx plus c. This was e. So I can rewrite again summation y minus, this term was what? Y hat, y prediction. So y hat. So I can try to rewrite this entire MSE by c is equals to minus 2 by n summation of y minus y hat. So this is going to give you the MSE. Now, if I'm able to find out this partial derivative, I have to find out what? I have to find out the new value of c. So new value of c is nothing but old value of c, learning rate, into MSE by dc. This one. So now I can rewrite eta, and this I can try to use as a this one. So eta minus 2 by n summation of y minus y hat, right? So if I'm going to like break it down, so it's going to be old minus minus technically will become plus, then eta over here उधर रख दीजिए अभी के लिए, ठीक है? Okay, so plus, and then like it will become 2 by n summation of y minus y hat. This is something that I will be able to find out. Now give me the new value of c, guys. What is the new value of c as per our data set? So new value of c is, what is c old? C old was 0 plus eta. Now eta is equal to 0.1. I'm going to consider 2 by n, number of data set is equal to 4, right? And the summation of y minus y hat. So by my y hat was completely 0, right? And my y was 57911. 57911. So here summation of 5 minus 0 plus 7 minus 0 plus 9 minus 0 plus 11 minus 0. Okay. So this is this. Now give me the new value of c, guys. Anyone? Give me the new value of c. Okay. So Sada is saying new value of c is equals to 1.6. Okay, fine. Considered. So new value of m is basically 4.5. I think this was the value that we were able to find out. New value of m was 4.5, right? 4.5. And the new value of c, I'm able to find out 1.6. Now my equation will become 4.5x plus 1.6. So can I say this will be my equation now? Yes. Can I say this will be my equation now? Agree everyone? This will be my equation now. Agree? So this is my new equation. Yeah. This is my new equation for a particular data set, because I have calculating everything based on my data set. So this is my new equation. Now let me rewrite my data set once again here. Okay. So let me rewrite my data set once again. So X and Y, 1, 2, 3, 4. So 5, 7, 9, 11. Now let's try to find out a Y hat with respect to this one. So give me guys Y hat with respect to, so prediction based on this equation. So based on this equation, let's suppose I'm considering equation number 3. So based on this equation, give me the value of prediction. So past value of X is equal to 1, X is equal to 2, X is equal to 3, X is equal to 4. Now give me all the value for X is equal to 1, 2, 3 and 4. Quick, everyone. We have a new equation guys. So we have started with M is equal to 0, C is equal to 0. Now M became 4.5, C became 1.6. Yeah, give me the value. Quick, 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 everyone. Yes, waiting guys. Yeah. So people are saying that it's a Sadai is saying 6.8, 15.1, 19.6. I think it's a correct one. Yeah, Raj is saying the same thing. So fine. 6.1, 10.6, 15.1, 19.6. Okay. Now this is something that we are able to find out. Now give me MSE. MSE is nothing but 1 by n summation of y minus y hat of a squared. So now we have a y, we have a new y hat, new prediction, right? Now give me what is the MSE value. So basically it's nothing but 1 by n, which is 1 by 4 summation of y minus y hat. So 5 minus 6.1 of a square plus 7 minus 10.6 of a square plus 9 minus 15.1 of a square plus 11 minus 19.6 of a square. Give me the new MSE guys, everyone. Give me the new loss. So what is the new loss that we are able to get? Yeah, so almost everyone is like able to do the same thing. Same answer. Bharti, Sivani, Ayush, Masood, Raj, Sada. Yeah, answer is same. Give me the MSE, new MSE. Yes, guys, what is the new MSE? Quick. What is the new loss that we are able to get? $31.33. Is it correct? Shivani is saying 31.33. So can you please verify other people? 30, Raj is saying the same thing. 31.33. Fine. 31.33. Now tell me one thing. What was a MSE when M is equals to 0 and C is equals to 0? And what is a MSE when M is equals to 4.5, which is a newly find value, and C is equals to 1.6? So what was the MSE, guys? So MSE at this point is, so loss at this point is 31.33. And what was the loss when M is equal to 0, C is equal to 0? If you remember, 69, I believe. Loss was M is equal to 0, C is equal to 0. What was the loss? 69, right? What was the loss? So it was 69. So can I say that by finding out a new value of M and by finding out a new value of C, and during that process, so we have taken a partial derivative of mean squared error with respect to M, partial derivative of mean squared error with respect to C, we are able to decrease the loss. Can I say that we are able to decrease the loss? Yes. Can I say that we are able to decrease the loss? Now I will try to do the entire operation. Means again I'll try to find out the new value of M, new value of C. Again I'll try to find out the new value of M, new value of C, and I'll keep on doing it. I'll keep on doing it in a loop unless and until I'm not able to reach out to the situation so where my loss is not changing. So let's suppose after a certain stage my loss is not changing at all. It simply means that I'm able to converge myself. I'm able to achieve a minima, right? I'm able to achieve the minima, maybe a global minima or maybe a local minima. So I'm able to achieve the minima. This is what we are trying to do with respect to a derivative, right? So we are trying to slope it down, or we are trying to achieve the minima. Now beyond this point, I can't change the MSE. So when we will not be able to change the MSE, and whatever value we will be able to find out at M for M and C, can I say that that is going to define my final line? Now with respect to the new value which we get now. So again, if you are going to find out a new value of M and new value of C with respect to the old M is 4.5 and 1.6. So eta learning rate, and then again rate of change of MSE with respect to basically like M, and minus eta rate of change of or partial derivative of MSE with respect to C. Again, if I'm going to do the math over here, after finding out the derivative, right? After finding out this particular part, which we have already defined in an equation. So now you don't have to go through all these things. Now you can just take the final equation like this one, right? You can take just the final equation, this equation, because technically my new C is nothing but old C plus eta 2 by n summation of y minus y hat, right? So now we have a new y hat, right? We are able to find out the new y hat, right? So with respect to the new y hat, again, can I say that my M will change, my C will change. So my finally loss will change. So I will keep on doing it in a iterative way again and again and again, unless and until my MSE will stop converging, means it will stop reducing itself. And at that point, whatever value of M and C we will be having, that is going to define my line. So I can say that here, when M is equal to 4.5 and M is equal to 1.6, it's a better line as compared to when we had M is equal to 0 and C is equal to 0. Can I make a statement? So this line that we are able to draw with respect to my data, so this line is a better one. I'm not saying it's the best one, right? But I can say that it's a better one as compared to the line that I have drawn where M is equal to 0 and C is equals to 0. Yes, everyone. Now, this entire process which I have explained you, so where again and again I'm trying to find out the value of M and C, I'm trying to reduce a loss, is called as training, basically, is called as training. So whenever you try to put up your data set into any algorithm, which we are going to do it tomorrow programmatically, right? So again, someone has written a Python code, right? And someone has written something inside that Python code. That is the reason. So it is giving you, you are saying that it is doing a training, it is building a model, right? So this is what happens internally. This is how it will converge. And finally, you will be able to get a value of M and C where that line is going to define the complete trend of the data set. And now this line with MS, this line is called as model. This is the model. That's it. This is actually a model. You will pass the data, you will get the prediction. So this is something called as actually a model. So when we say that we have built a model, In case of linear regression, again, algorithm to algorithm, it is going to change. So if I'm going to teach you a next algorithm, this equation is not going to be same. It is going to change, right? With respect to that algorithm. But in this situation, in case of linear regression, this is the model that we are able to find out. I'm just going to save this model in some file or anywhere in some variable. And whenever new data will come, it will try to pass X, give me my Y. That's it. And how we are able to achieve this point? By converging my loss, by reducing it as much as I can. Understood, everyone, guys? So what goes behind the scene in terms of mathematics, and manually we are able to do the calculation. So if I'm going to do it more, like 4 times more, if I'm going to do the maths same thing, if I'm going to repeat it 4 times, you will be able to see that my loss will be maybe like a very, very less. So is this a gradient descent optimization technique? Exactly. This is a gradient descent optimization technique. Fine, everyone, guys? Are you able to understand? Yes. Any doubt? Anyone? Okay, so now question. You can try to, you can ask me. So here Abhishek is saying that can MSE be negative, sir, at any point? MSE you are talking about, right? Look into the equation first of all. Look into the equation. Just by looking into this equation, right? Just look into this equation. Can MSE be negative, guys? Just look into this equation. See, you don't have to ask me that question, right? So just tell me, can MSE be negative in any situation? No, right? See, it's a square that we are doing. So if I'm doing a square at any point of a time, it can't be negative, right? I think someone has asked me this question. Who was that person? So Abhishek has asked me this question. So Abhishek, I think you got your answer. Yeah? MSE can't be negative at any point of a time because it's a square. Calculation wise, it's a square. So not possible. Now, next question is, okay, gradient, is this a gradient descent optimization? I think I've already given the answer. So this is called as gradient descent. Means we are trying to decrease, or we are trying to achieve a point minima over here. We are trying to descend as much as possible. So descend means what we are trying to descend? Loss, by the way. Now, Masood is saying learning rate. Okay, let's talk about learning rate now. Fine. So I simply said that learning rate is basically a hyperparameter. I can take any values. Fine. Now, how it can be found is not a question, by the way, over here. Basically, this learning rate which I'm trying to consider, which is a eta. So this is a constant value or configurable value that we try to take and we test it with the multiple different example. Now, I'll give you one example over here. Let's suppose, so to calculate a Cn in this equation itself, so what was this entire factor? So this was 5 plus 7 plus 9 plus 11. So 5 plus 7, 12, 12 plus 9 is equals to 21, 21 plus 11 is equals to 32, I believe. 32 into 2 is equals to 60. 4 divided by 4 is equals to 16. So this entire component, I'm considering, let's suppose this one, just to explain you learning rate. Okay. So Cn, I'm going to write, previous one was 0. I have taken learning rate is equals to 0.1. And then this value which I was able to get is 16. This value, this entire value which I was able to get was 16. Okay. Now, if learning rate, I'm going to take 1, 0.1, right? 0.1. So whatever value I'm able to get from partial derivative of MSE with respect to partial derivative of C, which was 16. So it is not taking the entire partial derivative value, right? So learning rate is stopping me to take the entire partial derivative value that we are able to get. It is allowing me to use a fraction of it. And proportionally, it will try to change a value of C. Now, let's suppose learning rate I'm going to consider, because it's under my control, I'm going to consider 100. Now, what will happen, guys? In that case, can I say that my Cn will be 1600, which is going to be very, very big, right? Which is going to increase my loss more and more. Now, if I'm going to take learning rate 0.01, right, my Cn will become 0.16. My new value of C will become 0.16. So here learning rate is called as hyperparameter. Hyperparameter simply means that I can try to train it. I can try to find out the best possible values. Now learning rate always try to tell you that, okay, you are trying to make a changes, but how much? Because this portion will be constant, right? This portion will be constant because this is coming from the previous values. Now, so whatever changes you are doing, so this is coming from this place, right? So this place is trying to give you the changes, actually changes into the entire values. Now, so learning rate is a parameter by which you will be able to control that if change is happening, how much changes. If it's too much, let's suppose your learning rate is very, very high. So for example, I'll try to give you some real-time analogy. So let's suppose if you're trying to, someone says, and I have seen the YouTube videos as well, that I'll teach you data science in 1 day, 1 week, and in 1 month I'll teach you data science, right? Now over there, can I say that learning rate is very, very high? That person is trying to claim that your learning rate will be very, very high. Very soon, I'm going to teach you everything and you will become a data scientist. Yes? Now, what will be the outcome? Now, will that person who have just studied a data science in just 1 week, will that person be able to crack the interview? Answer, guys? Do we need to memorize this formula? I mean, like, there is nothing to memorize over here. There is no formula over here, right? The new value is equal to old value minus eta into rate of change of like loss with respect to a particular parameter. That's it. That's the only formula that we are using. I have shown you just a derivation to give you explanation, right? But the actual formula is very simple. Is the new value is equal to old value minus learning rate into partial derivative of loss with respect to that parameter. That's it. Okay, now coming to my, so everyone is saying nope. No, not at all. No. Masood is saying, Sri is also saying no. So if my learning rate is very, very high, I will not be able to get the outcome. Maybe I will be able to change the value. Change the value means if someone is teaching me data science, maybe I will be able to understand some buzzword. But at the end of the day, outcome is what? Interview. I will not be able to crack the interview. So here you will be able to see the same implication that if my learning rate is very, very high, so it will end up generating more losses. Now, if my learning rate is very, very slow, 10, 0, maybe something like that, 10, 15, 0, and then 1. So this is my eta. Let's suppose I'm going to consider, right? So if someone is going to take maybe a 5 year of time just to learn the machine learning, now will that person will be able to like crack the interview? Again? So let's suppose someone is taking 5 years to learn a machine learning. So will that person will be able to like so basically when I'm saying eta is equal to this much, which is very, very low. So the changes which I'm trying to make, can I say I'm just trying to make a very, very like less changes with respect to the previous value? So again, can I say that it is going to give me the penalty, it is going to give me the loss, and I will not be able to converge. Converge means I will not be able to reduce a losses frequently. Yes? So this is where we try to take such kind of a values which will not be too high and which will not be too low. A balance, right? So the ideal value generally we try to consider is 0.1, 0.001 and 0.01. These are the ideal value that we try to consider, but it's not constant. Don't take it just because I'm telling you. No, you have to experiment. That's the reason it's called as a hyperparameter. Means I can train it, I can experiment it, and then I am going to decide the final value. Hello sir, you told me to remind you about the doubt I asked you. Yeah, Teddy, but yeah, I don't think that I will be able to get a time. So maybe tomorrow, whenever. I think Teddy has asked me basically with respect to, so Teddy, just to summarize your doubt, and even I have pinged you like a couple of examples. So see, It's a language basically. So when we say H0 and HA, Teddy has asked me a question basically with respect to like a null hypothesis and alternate hypothesis. He was having some sort of a confusion. So he pinged me on a WhatsApp. I have given him some example as well. So Teddy, it's more like a language, right? If we are going to change the language, then null can become a alternate can become a null. And based on that, we do the comparison. Just to answer your doubt. Now, so here, let's try to understand this part. So here we have eta. So eta should not be very high, eta should not be very low, and eta is something that we decide. Means learning rate is something we decide. So even in a real life, right? Real life, I'm going to decide that, okay, I'm going to take 6 months of time to learn a data science, which is not a very less amount of time, which is not very big amount of time. It's a balanced one. Yes, guys? Can I say that? Even in real life, so we decide our learning rate, right? That, okay, so I'll just try to join this batch. I'll try to spend maybe 4 to 6 months of time, and then fine, I will be able to learn the entire data set, which is not very big, which is not very small. So it's a balanced one, right? It's a balanced one. And based out of that, I can assume that I will be able to get a best outcome. I'm not saying that like one of the best, but yeah, maybe I will be able to get the better answer, better outcome out of this one. So this is the roles and responsibility of eta that you are able to see, right? This is the roles and responsibility of eta, nothing else. So hope all of you are able to understand the derivation. Now those who thinks that you have to memorize any equation, so believe me guys, I have not written many equation over here. I have just given you equation y is equals to mx plus c, and then I have given you one another equation which is a mean squared error, a function to find out a loss, which is nothing but n is equals to 1 till, sorry, so I is equals to 1 till n, I is equals to 1 till n, and then y minus y hat means actual y minus predicted y square. And then I have given you the equation. So Cn is equals to C old minus learning rate, rate of change of MSE or partial derivative of mean squared error, which is this function with respect to C, and new m is nothing but m old minus eta, like a partial derivative of loss with respect to C. I think this is the only equation in this entire class I have discussed. Apart from this, I don't think that I have discussed any other equation. No need to learn. One is the equation of line. One is to find out the losses, a difference between y and y hat, the prediction and the actual y that we are able to get. And the another one is to change the value of m and c so that I will be able to find out the optimized value of m and c. That's the only equation that I have discussed in my entire session. And none of the equation you are supposed to remember. It's fine. It's a very easy one, and it's just like a storytelling, right? That ultimately I'm trying to find out value of m, value of c. That's it. It's just like a story. Making sense to all of us, guys? Everyone? Now, any doubt? So what is called as training? What is called as model? How we try to find out the best fitted line? I believe all the answers are clear now. If not, do ask me a question. Clear all? Rahul is saying, sorry sir, disturb you. Rahul, I was trying to find out the recording, but I was not able to find out. So we do a lot of live classes, right? So not sure where that recording is. So even I asked my team to find out, but really sorry, we are not able to find out. So maybe Rahul, for one session, you can look into the English one. I believe for one session, you can try to like just go through the English lecture, because in English lecture, I taught the same thing, which I used to teach in a Hindi. Okay, any question guys for me? Are we comfortable with this entire derivation, guys? Anyone who is not comfortable with this entire derivation that we have done in my today's class? Starting from the analogy. tomorrow will be all these things during with respect to so programming, application building, and then EDA we are going to perform. So first of all, we are going to take the data. Then obviously we have to perform the EDA operation. We have to normalize the data over here, or we have to standardize the data. We have to handle a null value inside the data. If there is a null value, we will have to handle the imbalanced data. If we have some sort of an imbalanced data inside that, then we have to divide a data into a train and test split. Then we have to train the data, then we have to test the data, and then we have to evaluate the model. And after evaluation, we'll try to finally build a UI interface from where people can insert the data, and finally anyone can get the prediction. So a complete end-to-end app, and then eventually we are going to deploy that app in a cloud platform so that your app will be public and anyone can go and anyone can try to use that particular app. So that is a flow that we are going to discuss tomorrow. So in programming, in case of programming, all of this derivation which I have given to you, it's just equivalent to one single function. That's it. One single function and all will be done. But I'm trying to explain you these things so that you will be able to understand what goes inside that particular function. So when I say we are trying to train, when I say we are trying to converge, when I say we do a gradient descent, when I say that we are trying to build the model, now what does that mean? What we are trying to do behind the programming? So that will be the agenda of tomorrow's class. Hope that makes sense. Yeah. So fine guys, with that, thank you so much. Let me share this entire sheet. So LR discussion math, and I'm going to upload this sheet inside your dashboard. So tomorrow we'll build one application. Upload. So upload it guys, and hope things are fine with all of you. Okay, so I have already uploaded the sheet. With that, thank you so much everyone. See you again in my tomorrow session. Tomorrow we'll be doing a practical. Thank you everyone. Thanks. Take care.